Assalamu alaikum, it's Asad Yusuf, medical physics specialist. Today's topic is reflection on LINAC brand. Before starting, I would like to disclose that this content of presentation is based on my personal research and experience, intended for information purpose only. Any view and opinion or recommendation shared are my own and do not necessarily reflect my company. I do share the references, though. Furthermore, the information provided here should not be considered as a financial, legal, or professional advice. Please consult with a qualified professional for specific guidance. I don't have any sponsors from anyone. The agenda of my presentation includes the physical design, architecture of accelerator, magnetic design, magnet design, LINAC head design, dosimetry, MLC couch system, imaging capabilities, and motion management. So this is what the design is, Varian and Ela. So for the Varian, it's a whole machine that you are seeing, but for Ela, it's a half picture because half of the picture is a back door. It just, of course, look like this. And this is a schematic diagram. So let's talk about architecture of Varian LINAC. It's a true beam design, and it has a triode electron gun, which inject the bunch of electron into the accelerator. The bunch of steering coils steer the electron into the accelerator. This waveguide is standing waveguide, and the microwave generated from modulator are amplified by the klystron, and then microwave go into the accelerator, which work as waves for the electron, helps to travel from one point to another point. Once it get the certain energy, it moves to the bending magnet. It's a 270-degree bending magnet used. So the low energy and high energy will scatter out, the filter out, and only the desired beam will pass on from angle steering coil and hit the target and generate the photons. On the other hand, if we talk about Ela design, here we have a traveling waveguide, which is in a large size as compared to the standing waveguide. This system uses magnetron for the microwave generation, and thus has electron gun, a simple dielectron gun. For the high energy, it increases the beam current. On the other hand, for the Varian model, it has energy switch and increase the microwave generation so that high energy can be used, whereas the magnetron has a constant microwave generation, no increase in that. Only the beam current will change the beam energy. So the comparison, the top things I already covered. Yes, the bending magnet in a Versa HD is 112.5, as you can see here in this diagram. The purpose is same. MU ion chamber. So Varian has a sealed ion chamber and it has unsealed, so it is affected by the ambient temperature pressure. High energy switch is used in beam current for the change in energy. MLC system is agility, whereas what's sorry, it's being mistaken. It's which reverse. So can be changed. Like Millennium MLC and IGMLC should be here in the true beam, and the agility will be in the Versa HD part. Sorry for that. So agility Ela system, it has 160 MLCs of 0.5 cm in size, and can cover 40 by 40 field size and make island shape as well. And from my experience, when one eye center, we can easily treat bilateral breast The MLCs are placed in the placement of wide jaw. There's no wide jaw in this design, so there is MLC. So MLC size a bit, thickness is a bit higher as compared to linear MLC. Because it's a tertiary MLC, it lies after the jaws. That's the comparison between Electa and Varian design. You can see the leaf end, it's a bit different as compared to Varian. So speed-wise, the Millennium MLC is 2.5 meter per sec, whereas agility gives 3 meter per sec, and the carriage speed is 3.5, so it gives a higher speed and treatment delivery. The pairs of 0.5 of 80 pairs, whereas this 0.5 in the middle and periphery is 1. Tongue and groove effect is very low. The leakage is quite low in agility. Let's talk about the imaging system. So Versa HD has a manual imaging arm, CT arm, and fixed XVI and MV measures in a fixed position, and they can only be moved from inside the room. The field size is a bit smaller for the MV imaging as compared to a TrueBeam field size, but the XVI has a vast capabilities of taking an image. Manual bow-tie filter has to be inserted in the system. Whereas for the Varian is a robotic arm imaging system, and it can move from 140 to 100 isocenter cm from the isocenter. It can cover a large field. Additional information about the energy of imaging. Varian gives the option of 2.5 energy just for imaging, MV imaging, and you can see the results on Las Vegas. Beam quality is good. As low energy, as you can see, the KV is good for the imaging. So the in MV range, 2.5 gives much better result as compared to 6x. Additionally, you can try 6FFF, which gives a better imaging as compared to 6x, and you can see the result here as well. Console, it's compact, fully compact system, friendly system, easy to use. And the console is quite good. You can easily control your imaging array and couch from outside. And the service mode is quite compact. You got every option for the physicists and engineers. Whereas Electra console is a bit messy because each and every system is separate. This is integrity, this is KVI, XVI, and this is for the couch hexapod. So all the systems are separate, and you also have then consoles, the CPUs, separate CPUs to take a lot of space. And you can see in the console as well. And this is a separate response box. The key is here, and this is the console. 6-top couch. So Varian give a 6-top couch option without any frame, whereas Electa couch has a called hexapod, and it has a frame reflector there. It's detected by this camera. So it gives a bit limitation, like if the patient is quite bulky or heavy, can't fit on this frame. So that's the drawback in this couch. Other than that, it's both are quite good. Laser guard systems provided on Varian as a manual um, guard system, manual detection system is on Electa. Motion management. So Electa use ABC, gives ABC option, ABC active breathing controller. So it act like in this way you position the patient, and this device is detected attached with that computer system that you seen, and one of the laptop is on the console to monitor the breathing of the patient, breathing pattern of the patient. So, sorry for the pause. 4D CT and gating system. Varian use RGS system for active rating component, also for the CBCT. They have to place a block which has a reflector detected by the camera, and you can see the breathing pattern outside the console. Whereas for the 4D CT, Lecta doesn't use any block or a camera. It automatically detects via XVI system, and it gives the parameter which we can use for the contouring or for ITV. Remarks for the Lecta, pros and cons. So it's cost effective, power consumption is less in standby mode, head clearance is about 45 centimeter, multiple arcs in a single beam. That's a very good option for fast treatment delivery, precise large field MLCs. Cons: all systems have separate interface, manual imaging arm, manual bow tie filter insert. Monthly track is recommended because of the beam current. Electron gun has limited lifespan. If you're treating around more than 35 patients per day, it is expected that it could be replaced on air. Um, quite if you control the current or the voltage on a monthly basis, you can increase the lifespan as well. So monthly track is recommended from the Lecta side. So for the remarks of the Varian, compact and user-friendly system, robotic imaging arm, automatic daily QA device. It also gives the hyperarc option for SRS patient in planning and also in delivery side. Expensive machine, higher power consumption, and standby mode. Final remarks from my side, both systems are highly capable and offer similar capabilities in terms of treatment modalities. They were the excellent choice for highly precise treatment like SRS, SBRT, VMAT, IMRT, and other advanced techniques. These are the references. So my recommendation is to keep an eye on upcoming technology and upgradation, which may improve the quality of patient treatment and staff experience. I'll be happy to answer the questions that you put in the comment box. Thank you very much. Thank you for listening.